Hey guys, I'm back. The last thing we're going to do today is learn how to name an ionic compound. Let's go. Okay, so when you're naming ionic compounds, know that all ionic compounds have two and only two parts: a cation, the positive ion, and an anion, the negative ion. You must have both a cation and an anion for an ionic compound to exist, and you cannot have more than two types of things. You can't have a cation, an anion, and a neutral species. It's just two parts only. In order to name an ionic compound, you must identify these parts. Figure out what's the positive and what's the negative. So when you're naming ionic compounds, for the cation, the positive part first. Positive always comes first. If it's an element, just write the name of the element. If it's a common ion, just write the name of the ion. If it's a transition metal or it's under the stairs, a metal under the stairs, excluding silver, zinc, aluminum, these are on your common ions chart, and we're going to talk about those later. These do not follow that rule. You should write the charge of the element in Roman numerals. 1 looks like this, 2, 3, 4. You'll typically only ever have 1, 2, possibly 3. You're not likely to have 4, but there they are. For the anion, the negative ion, if it's an element, change the ending of the element to "ide." So fluorine would become fluoride. Chlorine would become chloride. Oxygen would become oxide. Sulfur would become sulfide. If it's a common ion, just write the name of the ion without changing anything. Don't worry about it at all, just write the name of the ion. Also, you do not need to worry about the subscripts or how many of each ion there are when naming compounds. So when you were doing BeF2, when you're looking at the names, it does not matter that you added a 2 there. You're just looking at the Be and the F alone. The 2 is not important for the name. It's important, but not for the name. Let's look at a couple examples. So again, on your formulas paper, the ones that you've already written the subscripts for, number 1, you've already have the Be and the F, and you've put a 2 right there next to the F. And now you have a line next to that, and you have to name it. So first thing we're going to do is look at the cation. For the cation, you write the element name if it's an element. And Be is an element, and the element is beryllium. Beryllium. I will not take off for spelling unless you spell the wrong word. And if you spell the wrong word, then I'll take off because it's not really a spelling mistake. That's it. Beryllium is not a transition metal. It's not under the stairs. It's just a plain element. That's it. Just beryllium. Then we look at the other part. The other part is fluorine. Doesn't matter that I put a 2 there. It's just fluorine. So I'm going to take this fluorine, I-N-E, and change it to F-L-U-O-R-I-D-E, fluoride instead of fluorine. And that is the word that goes in your blank. That's the name of that compound, beryllium fluoride. Let's do another one. Now we have LiNO3, and you didn't even write any subscripts on this one, it just stayed as LiNO3. So Li is an element. The element is lithium. So Lithium. It is not a transition metal. It's not underneath the stairs. It's just a plain element. So it's just the word lithium. Then our anion, NO3, from your common ions sheet, that's called nitrate. So you write nitrate. Nothing weird or special or fancy about it. It's just nitrate. So this is lithium nitrate. So let's do another one. Eventually this is going to get tricky, right? We have Sn plus 4. So Sn is the element tin. You're probably going to need your yellow periodic tables for this so that you know what each element is and you know how to spell the words. But if you look at tin on the periodic table so that you find out that Sn is tin, notice that it's underneath the staircase, which means it's going to need a Roman numeral. And the Roman numeral is going to be equal to the charge. So since it's Sn plus 4, it will be tin 4. So tin, parentheses, IV for 4. And then that's it, tin 4. Instead of calling it plain tin, it'll be tin 4. And then for our second ion, we have SO3. According to your common ions paper, that is called sulfide. sulfite, not sulfate. So this is tin for sulfite. Let's do just a couple more examples, and then I'll let you on your own. We have Mg. Mg is magnesium. It is not a transition metal. It is not underneath the stairs, so it's just the word magnesium. Then we have C2H3O2, which is acetate. I got that off my common ion sheet because I have my common ion sheet memorized. That's it, magnesium acetate. It doesn't matter that earlier when you were writing the compounds, you put the little parentheses, then you added the 2, just magnesium acetate. I'm going to do one more with a charge, and I'll give you a hint. You know already which ones have charges because the charges were written on there for you. So instead of aluminum chloride, I'm going to do Cu plus 2O. And you probably changed that to just CuO because O is minus 2. So the reason why they said Cu plus 2 is because copper is one of those that needs a Roman numeral. Its charge could be plus 2 or plus 1. So they're trying to tell you that this is specifically the copper that has a charge of 2. So you put copper with Roman numeral 2. Then we have oxygen. But for an element at the end, you don't leave it ending as oxygen. You change the ending to "ide." So this oxygen becomes oxide. So that's copper 2 oxide. If you ever have a plain element at the end, change the ending of the word to "ide." Sulfur becomes sulfide. Chlorine becomes chloride. Oxygen becomes oxide. Hydrogen becomes hydride. Whatever's at the element at the end, change it to "ide." Element at the beginning, leave it like it is. So your homework this weekend is to make sure you've written the subscripts and the names for each one of these compounds on this paper. You guys have a great weekend. I'll see you on Monday.